In this lesson, we're going to learn how to solve a linear system that has inequalities. And this is just going to be real similar to what we learned a little bit before when we learned how to graph a linear inequality. That would be some sort of a linear equation that has inequality sign instead of an equal to sign. So we're going to go ahead and do that. And in this one here, the second one, that should not be an equal to sign. That should be an inequality sign. So let me change that. Okay, so now what we need to do is we're going to substitute one of these points, this point, into both equations and see if it's true in both equations. If it is, then it's a solution. And so I have three different pairs here we're going to check. So let's start with the one 6, 7 first. So in the first equation, if I substitute the 6 in for the x, I would have, so this is 0.67. I would have 5 times 6 minus 2 times 7, is that greater than 16? 5 times 6 is 30 minus 14, is that greater than 16? I have 16 greater than 16. That's not true. So it does fall on the line, but notice that this has an inequality without an equal to sign, so we get 16 greater than 16. That's not true. If it would have been 16 is greater than or equal to 16, then it would be true in that first equation. So we can already see that the ordered pair 6, 7 is not a solution. Let's try the second one, 2, 2. And I'm going to substitute it into the first equation. So I would have 5 times 2 minus 2 times the y value is 2. Is that greater than 16? 10 minus 4 greater than 16. 6 greater than 16. Well, just substituting that value into the first equation again wasn't true, so I don't even have to go any further. I can see that that's not a solution. Let's go to the final one, which is 4, 1. So let's try 4, 1 into the equations. So I would have 5 times 4 minus 2 times 1 is greater than 16. 20 minus 2 greater than 16. Is that true? I would have 18 greater than 16. Yes, that's true. So it works for the first equation. Let's substitute it into the second equation. So I have y is less than or equal to 2/3 x, so the y value is 1, is less than or equal to 2/3 times an x value of 4 plus 3. 1 is less than or equal to 8/3 plus 3. Well, obviously, 1 is less. If 1 is less than 3, it's certainly going to be less than 8/3 plus 3. So we could see right now that it works in that also. So both of them are true. So that ordered pair is a solution. Now, when we solve these inequalities graphically, all we're going to do is just graph them, and the overlap of the shading is the solution. So we should know how to do this from our previous work. So let's take a look at the first equation. 8x minus 5y is greater than or equal to 25. These are in standard form, so I'm going to use the x and y intercept method to graph them. So for the first one, that's an inequality sign with an equal to sign, so that's going to be a solid line. And we see that if I put a y of 0 minus 5y is 0, then what I would get as a point to plot, I would divide 8 by, let's just go ahead and show the work a little better. So if I put a 0 in for y, I would get 8x, and we're going to use an equal to sign because we're looking just for points on the line. So I would get x is equal to 25/8. And that's when y is 0. If I put x equal to 0, I get the y-intercept, and you can see that that would be a minus 5y is equal to 25, so y is equal to negative 5. So let's go ahead and plot that. 25/8 is just slightly greater than 3, so the x value would be slightly greater than 3. The y value is a negative 5. And we said it was a solid line. And let's test to see which side to shade. So I'm going to substitute the 0, 0 into this equation. That would be this point here. We'll see if we're going to shade that side. So that would be 0 minus 0 is greater than 25. That is not true. So we wouldn't shade that side. We would have to shade the opposite side of 0, 0. So this side would be shaded. Okay. Let's go to plot the next line. Let's use a different color, maybe green. So actually, let's change that to blue. So for the next equation, once again I'm going to use the intercepts. It's going to be dashed. If I set y equal to 0, the x-intercept would be 10. If I set x equal to 0, y would be equal to 6. Let's go ahead and plot that. 0, 6, and 10, 0. It's a dashed line. Let's see what side to shade. So I'm going to plug 0, 0 into this equation. 0 plus 0 is less than 30. So the point 0, 0 there, that would be shaded. So you can see that my actual solution is going to be this area here, the solid line on this side, bounded by the dashed line on this side. And so this whole region down here, any point in here, would be a solution to the equation. Okay, let's go on. Let's do another example. These are in slope-intercept form. So let's graph the first one. We have a y-intercept of 2 and a slope of 1. The coefficient in front of the x is 1, so up 1 over 1. It's going to be a solid line. And it says the values where y is greater than or equal to x plus 2. So let's test 0, 0. 0 is greater than or equal to 2. That's false. So 0, 0 is not shaded. Everything on this side, the other side would be shaded. Do the next line in a different color, blue. So what we have is a y-intercept of 7. It has a slope of 1 also. That's draw the line, and it's going to be dashed. Let's test 0, 0. 0 is less than 0 plus 7. 0 is less than 7. That's true. This one will be shaded downward then. And you can see, actually this would extend on, but the overlap is the area of the intersection. And you can see that the overlap is going to be bounded by the dashed line on that side and the solid line on this side and everything in between those two parallel lines. Here's another one just for reference in case you want to look at it or work it. It's a situation where we once again have parallel lines, but the shading is such that it shows up there. So let's do this one. This has 3 lines on it. See what we get here. So y is greater than negative 2x plus 5. That's in slope-intercept form. So let's put a point at a negative 5. And the slope is a negative 2. That would be down 2 to the right 1. And it's going to be a dashed line. Let's test the point 0, 0. 0 is greater than, I put a 0 in for x, I get a negative 5. That's true. So for this line, let's extend it on a little bit. That's good enough. This side is shaded. Let's do the next line. I'm going to use slope-intercept form. If I put a 0 in for y, my x-intercept, I would have 2x is a negative 4, x is a negative 2. The y-intercept, if I put a 0 in for x, the y-intercept would be 4. So let's try the blue. I have negative 2, 0. And I have 0, 4. Dashed line. Let's test the point 0, 0. 0 minus 0 is greater than a negative 4. That's true. So 0, 0 is shaded. And lastly, let's put the other line on there. X is less than or equal to 2. So I'll use the green for that. Here is the solid line right here. And the values where x is less than a negative 2 are going to be going to the left. And the overlap of all of that is going to be the little triangle in the center. So let's see if we can pick that out. It's going to start down here. And that would be my overlap. Okay, in this last example, what we have to do here is we're actually going to have to write the equations of the lines that produce this solution set. So what I'm going to do is I'm going to pick a line, and I'm going to call, let's just say this line down here, we're going to call that line 1. And I'm going to write an equation for that line. So for that line, you can see that it's actually at x equal to a negative 2, or no, sorry, y equals a negative 2. It's a solid line, and all the values that are shaded are where y is greater than or equal to a negative 2. So that would be all the shading going up from that line. So I know that line is y is greater than, and because it's solid, greater than or equal to a negative 2. Let's call this the second line. Let's work on it. So what I see is that the second line is passing through the y-intercept of 1. So this would have a plus 1. And it has a slope of 1. You can see that it up 1 over 1, up 1 over 1. So it would be x. Now the question is it going to be a less than or equal to or a greater than or equal to, because the line is solid? So let's just pick the point 0, 0 and test it in there. So I'm going to guess that it's a less than or equal to. So let's say it's a less than or equal to. And if I pick the point 0, 0, let's go ahead and just put that in there. If I pick the point 0, 0, I would have 0 is less than or equal to 0 plus 1. That's true, so I guessed right. If this wouldn't work out, I would have to change the inequality to a greater than sign. So either the less than or the greater than are going to work. I just happen to guess the less than, tested 0, 0, and it's true, so there's my equation. Okay, let's go down to the third equation. We'll call this one right here. That'll be the third equation. And we can see that we have the same y-intercept. We also have a slope going downward, so I'm going down 1 over 1, down over 1. It's the slope of a negative 1. And let's say that I think that this is a greater than or equal to. So I'm going to test the point 0, 0, because that's part of the solution, so it needs to be true. And that would give me 0 is greater than a negative 0 plus 1. 0 is greater than 1. Well, that's not true. So I guessed wrong on the inequality, so it must go the other direction. So I would put a less than or equal to. Let's test that just to make sure it's true. So if I plug 0, 0, which I know is a point, because 0, 0 right there is part of the solution, 0 is less than 1. That's true. So that's how I would write the system of equations that produce that. That's it.